All right, let me share the screen so you guys can see it. Do you guys see it? Is it clear?
Yes, sir. Yes, sir.
All right. So if you remember
Very.
previously, we have done all these things. Okay, we have calculated these materials. You can say the quantities of different materials, such as brickwork, PCC work, okay, and the plaster work, and let's add whitewash too. And let me have that maybe like 3 quarts, okay, on the fresh surface. So the whitewash is going to be the same thing as the plaster work because we're gonna whitewash the surface that is just plastered, you can say. Okay. So we have the whitewash is the same as the plaster work. Now, I want to determine the cost of construction, okay, of the same project. Like it is just a small project of a room which is 12 by 12. If you remember, let me just open date. Where is it? Yes, this project, okay. We have done it. And if you can see, it was the same thing like this. Okay, this thing, okay. So it was just a small room, you can say. However, a room in you can say some small project is the same thing because we have foundation, we have floor, we have roof, everything, okay. Doors, windows, everything available in the same small project. So it means it is like a project, okay, you can say, for a quantity beginners. So, as we have just calculated all these things in Excel, you guys can see the Excel, okay? Okay, so we have all these materials. Now, I want to determine their cost. You can say the cost of construction. So how can we do that? For this approach, you have to use MRS. If you remember, we we have already talked about these things before, okay? MRS. I have 2020, which is little bit old, but does not matter. It's just learning. Okay. You can download maybe 2023, maybe available on the internet. And this can be actually different according to the location you are living. Okay. So MRS is actually just the material rate system, or you can say just the material rate schedule, okay, because it is just a schedule, okay, having different costs. You can say the cost of labor, then the cost of material, or maybe composite, you can say, okay. So we'll just take the composite rate for different materials. And I'm not going to use all these small videos, okay? Let's say we have serial number over here, okay? I'm just making like a table. And then we have description. And then let's say we have maybe quantities, then maybe unit, and then maybe unit rate, and then you can say the total amount. Okay, so it is just like a small table, you can say, right? Let's have some border like maybe tick, so it's clear. And I'm gonna enter some videos. All right. So let's say we have maybe brickwork in the same project. We may have PCC work. We may have RCC work. There can be like excavation, which should be at start. And there can be like maybe whitewash in your project. And lastly, I would say there can be maybe stonework or maybe stone masonry. Okay, just the same thing as brickwork. So you can say brick masonry. I'm not just entering all these things because that's gonna take much time and our lecture maybe a little bit then lengthy. Okay, so let's say if we have the brick masonry, I'm not gonna take the brick. Where is it? Okay, where's let's say this one. Okay, I'm not taking the net brickwork is 382. It is just a small video. Okay, so let's say if we have brickwork is maybe 6,000. It is let's say it is a huge project, and then we have PCC work is maybe 3,000. Okay. And these guys are in CFT, you can say, right? And then let's say RCC. So maybe 1000, excavation, let's say this is 7000, okay, in CFT. And then we have whitewash, let's say maybe 3000 SFT, because this is just, you can say area. And then stonework, this is, let's say 2000, okay, CFT. CFT means cubic feet. Okay, you may have cubic meter, does not matter. Now, the unit rate, it means the composite rate. Okay, what rate we have in market. Okay, so it depends upon those things. Now, we have to just look into the MRS. Let me just have MRS over here. And the first thing, as you can see, we have the brick masonry, okay? So you can just search for brick masonry in your MRS, which is just a PDF, and let's just search this thing over there, okay? For this, you can even check the maybe the table of content, okay? If you cannot find your required work. Now, as you can see, this is chapter 7, and we have the brick masonry. So as you can see, in the same MRS, we have the brick masonry. Now, let's say we have the brickwork in maybe in ground floor or maybe in second floor. So you have to confirm those things if it's first class brick or maybe second class brick, okay? So these are the description. You can see it, okay? Let me just highlight if I can do it. These things, okay? These are just the description, okay? So let's just see if we have maybe let's say first class brickwork in ground floor, cement and sand mortar. We can even use this, but if you remember in our description it was 1:3, okay? So we can use this composite rate, which is of course 28,748 point something, okay? If you need to determine only labor, you can use this thing. But remember, this rate is not just for a one CFT, it's for 100 CFT, which is huge work. Okay. So what you have to do is just to convert it into one CFT and then multiply the rate with your same video, you can say with this one. Okay. So we have the unit rate, which is actually, let me just copy that. Where is it? It's maybe like 28, this one. Okay, let me just copy it and I can just paste it over here. This is the unit rate, okay? And this unit rate is actually per 100 CFT, okay? Now, what should be the amount? That's pretty clear, okay? You have to just determine the unit rate, which means per CFT. You can do it by using Excel functionalities, okay? What we have to do is just to divide this thing, okay, by maybe 100. So we can have per unit rate, okay? You can even just close those things with bracket and then multiply this with the uh, same quantity which you have and press enter. Okay, it is a huge video, very huge video. Okay, because we have, and let's just confirm if we have done that correct or not in Excel. Okay, so calculator is, I think, best option we have, and this is 0.83. Okay, and let's divide it by 100. So this is the rate per CFT, which is 287. Now we have huge work. Okay, that's 6,000. It means it's like a huge building, heavy project. Okay, so let's multiply that with 6,000. Yeah, this is good. Okay, so we have amount, and this amount is actually in RS, not in dollars, because this MRS is used over here in Pakistan. Okay, that's not US MRS. So I think you guys have understood how we can use MRS. Okay, I'll have just one another example. Okay, I'm not gonna spend much time with it because it's just simple thing. So let's look for the whitewash. What do you guys say? Okay, whitewash, and I'm gonna have whitewash in the same MRS. Let's just search for it. Okay, let's say whitewash. Okay, you should know about this search box. Okay, and there, as you can see, we have different type of whitewash, you can say in chapter 11. Okay, we have surface rendering, and this is whitewash old surface one coat. Okay, our surface is, let's say, new surface, okay? And we want three coats. So as you can see, we have this thing, okay? Whitewashing, new surface, and three coats. Okay, that's good. And we have the rate, which is 426. Let's just copy that rate into our Excel, maybe like we're here. And this rate is actually per 100 SFT. Okay, let me just confirm it. Yeah, it is per 100 SFT. So again, we have to just convert it. Okay, the same way is like this one. We can even drag this formula below so we can save time, and let's just remove these zeros. Okay, so this is the same thing. Okay, it means we have just divided 426 by 100, and then we have just multiplied that value with 3000. So we have the rate for the whitewash, and this is actually in RS. Okay, 12,797.1. So this is how you can use whitewash. There can be artwork, okay? Let's just look into the table of content. If you guys can, yeah, we're here. We have broad bridges, lining up canals, sheet piling, okay, and so on, protection and diversion works. We have outlets and so on, okay? So you can just have these things over here. Look at carriage, which means the carriage of material. Let's say we have maybe stones and we want to carry them. Okay, let's say we have 1,000 or maybe 2,000 CFT stonework. So what should be the rate of carriage? You have to look in the MRS. Okay, for that concrete work, we have mortar, the stonework, and so on. Okay, so this is how you can use, of course, MRS. Now, I'm going to just close this thing because we don't want to waste much time on this approach, maybe on this topic. Okay, the next thing which I'm going to do is actually uh, the same thing, which is the material analysis. Okay, are you guys there?
Yes, sir.
So we have material analysis, and I'm going to use the whiteboard for this approach because whiteboard can be better option. Okay. I can even do that in Excel. However, we will give it a touch, no problem. Okay. I don't like this whiteboard. Let me just open something like maybe uh, PowerPoint. Okay, PPT. I really like PPT. We will be just determining the breadth. Okay, and we will have some analysis, maybe just determining different materials used in it. Let's say if we have the brickwork, maybe the quantity of brickwork. Let's say if we have the quantity QTY, let's say it is 373, okay, CFT. It is the same video. It was just determined yesterday, okay, for the same room, if you remember. We have done this. We have 373 CFT. And let's say we have the ratio for the brickwork, and it is 1:3. Okay, so this is the ratio. Now, if we need to determine the quantity of cement, the quantity of sand, but let's say we have the number of bricks. So how many number of bricks should we just demand for this work, for the same work, okay? So the number of bricks should be calculated first. Now, in order to determine the number of bricks, you have to just multiply 373 with 13.5. What do you mean by 13.5? Because we have 13.5 bricks per CFT. Okay, if you have one CFT brick work, it means you should be using 13.5 bricks. Okay, so this is actually the volume of the brick work, and we have to just multiply that with the unit factor. Okay, so after multiplying these things, there can be actually the number of bricks, and these should be actually 5,040, which is huge video. Even you guys can confirm these videos, okay, with your phone or maybe with any other calculator. So we
Okay,
have,
sir.
so you guys have to just confirm these things because I'm just writing these things from, okay, maybe you can say approximate videos.
So we have 5,000 bricks, you can say, for the same project. Now, for the same project, let's just determine the quantity of cement. Okay, let's just determine cement. Now, in order to determine cement, of course, we need how much mortar we have in the same brickwork. This is actually the good question, okay? So first we have to determine the quantity of mortar. Now remember, the quantity of mortar should be 30%, okay? And this is actually dry mortar. 30% of the brickwork. So 30% of the brickwork is actually 30 by 100. And we will just multiply this with the brickwork, which if you remember, it was just 373, okay? So this should be now approximately 111 CFT mortar. Now from the same mortar, okay, this mortar actually contains two things. One is cement and another one is actually sand, okay? So we have to multiply these two things and these can be determined from the ratio, okay? We have 1:3. Now, the sum of ratio, we have to determine it, okay? The sum of ratio, which is actually 1 plus 3, and that should be 4, okay? So this is what we need to determine these two materials. I just gonna need to determine the cement first. And for this approach, and even, let me just erase these things, okay? These things. I should just write a specific formula for this approach, okay? In order to determine the quantity of anything, quantity of material, you can say, you have to take the ratio of the material, the ratio of the same material, okay? And you have to divide it by the sum of ratio. So it is like a formula, okay? And then multiply this thing, you can say this ratio with dry mortar. So now let's just determine the quantity of cement. Now the ratio of material, okay, just look at over here. The ratio of material, that is actually 1, okay, in the same ratio. Because 1:3 means, what do you mean by 1:3? Anyone just know about this?
One cement,
Yeah,
one and three sand,
Okay, so
one bag cement.
okay, so it's like the ratio of material, you can say the ratio of mortar. One represent it represents actually cement's quantity, and 3 represents the quantity of sand. Okay, so we have to take the ratio of material, which is actually 1 this time, and we will divide this by the sum of ratio. Now the sum of ratio, that is actually 4, and then we will multiply this with the dry mortar, okay, or you can say the dry volume. And if you remember, it is just 111. So 111, okay. So if you just multiply 111 with 1, that is the same thing, and then divide it by 4, so you will have 27 maybe CFT cement. But remember, cement is always just, you can say, bought in terms of bags, okay? We cannot demand it in terms of CFT because bags are available in market. So we have to convert this into bags. Now, in order to convert the CFT into bags, okay, you should know the volume of one cement bag, okay? And this can be different, okay? According to your country's bag volume, like maybe in Pakistan, it is 1.25 CFT, okay? So you have to multiply this, divide this by 1.25 in order to get the quantity of cement in bags, and these should be approximately 22 bags, okay? Next, we need to determine the quantity of sand. So you have to use the same formula, like maybe the ratio of sand, which is actually 3, divided by the sum of ratio, which is 4, and multiply it with the same thing, okay, which is the dry mortar. So this should be the quantity of sand, okay? And this is so simple, which should be 83 maybe, like 84 CFT sand. Okay, you can even convert this into sekadas, which is actually like local unit, okay? So you have to divide that by 100, okay? Which is almost like 0.84 second. It is local thing, maybe like 100 CFT is actually 1 second, okay? Now, it's really complicated to use this formula again and again, so it's better to use it like in short form, maybe, okay? Like if you see, we have 1:3, okay? Now the quantity of cement, it was just 27, okay? So you have to take that 27 and then multiply this with the ratio of sand, because sand is just 3 times of cement, okay? So we have cement is 27, multiply this with the ratio of sand, which is 3, and this is going to be the same thing is 84, okay? If I'm not wrong, 27 times 3, this should be 81, okay? So it means this should not be 84 then, okay? Let's just confirm it. So we have actually taken this thing approximate, okay? Because I'm not using calculator, okay? This thing is actually approximate. This one is approximate, okay? So we have taken approximation over here. You have to use the exact value in order to calculate these things, okay? Right? Like if you remember, we have just labeled 111. But if you multiply this thing, which is 373, okay, with 30, this is actually 11,190, and then just divide it by 100, which should become actually 111.9, okay, 111.9. So 0.9 is just been skipped. That's why we have some differences in the answers, okay, which is not, you can say, issue. Okay, so it means we have now materials like maybe cement and then sand.
सर
Yes.
सर ये 111 जो वॉल्यूम है मोटर का, इसके साथ 1.3 मल्टीप्लाई नहीं करेंगे तो ड्राई के लिए?
Basically, what happens is actually 30% is actually dry already. Okay.
नो सर ये बात नहीं करा.
What's your question?
सर ये 111 क्यूबिक फीट जो वॉल्यूम है
Yes.
मोटर का, ये वेट वॉल्यूम है ना सर? ड्राई में कन्वर्ट नहीं करेंगे? मल्टीप्लाई बाय 1.3.
This is what I'm saying, that 30% is actually dry. So 111, this is actually in form of dry volume. So we don't have to convert that. It's never wet. Okay. However, let's say if you have plaster work, okay? Let's say if you have plaster work, and that is, let's say, maybe 200 CFT, okay? So this can be wet. Then you have to multiply this with 1.27 in order to convert this into dry volume. What do you say? Is it clear?
Yes, sir.
Now next, okay, so this is how we can do material analysis for the brick work, okay? Let's do it for the PCC work. We will take the same video from the same room which we have calculated, okay? And let's say that is 13.8.2 CFT. It was just calculated, okay? The PCC work. If you remember, we have done it. Now the ratio for this, if you remember, it was just in the foundation, okay? And I think it was just 3 inches, okay? So you have to confirm that, no problem. It was, I think, 1:3:6 ratio, okay? So now, if you just calculate, okay, like if it was just in foundation, maybe like this, okay? So it's just like a slab, okay? We have 13.812 CFT, okay? And this is PCC, plain cement concrete. So when we calculate all these things, we actually multiply the breadth with the height or thickness and then with the length. It becomes actually the wet volume. Now, the ratio, that is 1:3:6, it means the summation of ratio or the sum of ratio should be 10, okay? Now, in order to determine the quantity of cement, let's just calculate cement. Okay. Remember the same formula. the ratio of cement, let's say the ratio of cement divided by the sum of ratio, okay? And we multiply this with dry volume, okay? So the cement should be now the ratio of cement, which is actually 1 divided by the sum of ratio, that is 10, okay? And we will multiply this with dry volume. Now, what's dry volume? Dry volume is actually the wet volume, which is 13.81, okay? And we will multiply this with 1.54. Now, 1.54, this is, okay, it may be varies depending upon your country and depending on the materials used in the same concrete, okay? I have read many books and this video is different, okay? It can be 1.50, it can be 1.51, okay? It can even be 1.49, okay? So it depends on the properties of the fine aggregate and then coarse aggregate and even depending on the cement. So why we take 1.54? This is a good question, okay? But before answering that, let's just calculate this value first. So the quantity of cement should be now, okay, if you multiply 13.81 with 1.54, this should be actually 21. And 21 times 1, this is the same thing. And we will divide that by 10, so we can have the quantity of cement, which should be 2.127 CFT. So 2.127 CFT is actually cement, right? Now divide this by 1.25 to have the quantity of cement in form of bags, okay? So we should have 1.701 bags. Why do we need to convert wet volume into dry? This is a good question. The question is actually, we're here, okay? We just converted the wet volume into dry by multiplying 1.54, okay? So why do we need to convert wet volume into dry? And why, what's
सर
1.54?
ड्राई वॉल्यूम सर ज्यादा होता है, जब हम पानी उसमें ऐड करते हैं तो फिर उसका वॉल्यूम कम हो जाता है, वो कंप्रेस हो जाता है सर।
Exactly. That's good. You are clear, okay? So what happens actually, if you see, we have aggregates like maybe crust stone, okay? These are crust stone. And there can be actually maybe sand like this, okay? And here we have cement, very fine, okay? So we have three materials, right? This one sand, and this one crust stone, or maybe coarse aggregate, if you use technical words. Sand is known by the fine aggregates. Now, what happens actually, if you bring, okay, if you carry the crush, okay, there are spaces, maybe voids, okay, these voids, okay, so these voids are filled with the quantity of sand, okay, and even these voids or maybe the voids in sand are filled with the quantity of cement. So this is actually the basic approach. And this is the idea, okay? So what happens is actually, let's say, if we bring 100 CFT crust stone, 100 CFT sand, okay? And even 100 CFT maybe cement, okay? Which is actually not the same thing, right? This can be 50 maybe, this can be 25, or even we can say, let's say if we have 1 CFT, and then we have 2 CFT, and then we have maybe 4 CFT, okay? Okay, let's not consider that, okay? So we have 1 CFT, we have 2 CFT, and then maybe 4 CFT as the crust stone, okay? So what happens actually, this is very, you can say this is maximum, okay? The volume is maximum, okay? We bring it in dry form, okay? Now, we know it in advance that after adding water or mixing these three materials, we may have the shortage of 54%. Is that clear? That's why we add in advance. Okay, we add 54% volume in advance. This is the basic concept. So for 1 CFT, if you add 54%, it means 1 plus 0.54. This becomes 1.54 for 1 CFT. So this is how we have 1.54. So this is how we can just calculate maybe the cement. Okay, where is it? We have 2.127 cement. So this is cement, and now we will just calculate the quantity of sand ratio. It was just 138. Okay. So what you have to do is to take the quantity of cement first, that is 2.127, multiply this with the ratio of sand, that is 3. So we should have 6.381 CFT as sand. Now, let's calculate the crust tone. We have cement, which is actually 2.127. Now, the ratio of crust tone, which is 8. Okay, so we will multiply that with 8. I'm not going to repeat those formulas like the ratio of the material divided by the sum of ratio times the dry quantity of the material. Okay, this is just for kids. So we will use these simple things, okay, times 8. So we must have maybe
Sir,
17.
okay.
Yes.
No, sir, 136 ratio.
Okay, we have 136. That's good. We have 136, so we will put 3 over here. You are good. Thank you. We have 6 here, okay? So it means that 2.127 times 6, this is actually 12.762 CFT. Thank you. That's good. Okay. So this is called, and this is known by the material analysis of PCC work. Is it enough, or I should move ahead? Okay, one another thing. Let's cover DPC, and I'm not gonna calculate these things. Okay. Now, what we have done in DPC, let's say if we have 50 SFT. Okay, remember DPC, it was just calculated in terms of area, if you remember. Okay. And now let's say if the DPC thickness, if we have thickness of the DPC, and that is actually 1 inch. So we have to convert this into volume now in analysis. Okay, you have to multiply this with 1, but 1 that is in inches, let's divide that by 12 to convert it into feet. We must have something in CFT. Okay, now this is actually concrete or PCC. So you have to use the same process. Okay, we just used over here for the PCC. Okay, so for the PCC, it is the same thing. Okay, for the DPC. Okay, and even it is the same thing for the RCC as well. Okay, so we are not going to discuss these things because we have already done it. Okay, now another thing, let's just say, why not we cover about the whitewash?
सर ये प्लास्टर वर्क का जो मोटर होता है सर, उसका वॉल्यूम कैसे फाइंड करेंगे? वो भी एरिया कैलकुलेट
Okay,
करते हैं ना?
let's consider plaster. So if you remember, we have already calculated plaster. Okay, can be anything. Okay, but let's say if we have that like 200 SFT. Okay, it was just the same thing in area, you can say. Now we have plaster thickness. Okay, let's say the plaster thickness that is maybe half inch or maybe 1 inch. Okay, so let's say if we have half inch, you have to convert this into feet by converting or dividing that by 12. Okay, like maybe 0.5 divided by 12. This is actually something like 0.041, okay, feet maybe. Okay, so now you have to actually determine the wet volume of the plaster. Okay, wet plaster, or maybe you can say wet volume of the plaster. So you have to just take the area. Now area times thickness, this is actually the same thing as volume. So we have actually the wet volume, and that should be, if I'm not wrong, this should be 8.34 CFT. Okay, so let's just say if we have the ratio for the same plaster is 1:3. This is the ratio. Okay, so let's just determine cement. Okay, it's clear. Okay, let me just make it clear for the others. So we have to take the ratio of cement, which is 1, and let's divide that by the sum up ratio, which is 4, because 1 plus 3, that is 4. Okay, now let's multiply this with the dry volume. We have wet, that is 8.34. Let's multiply this with 1.27. Okay, for concrete, it was actually 1.54. This time we have 1.27 because we don't have the coarse aggregates. And the voids present in the sand should be filled with the quantity of cement maybe. Okay, we consider it the same thing. In advance, we know that 27% may decrease after adding the water or mixing the aggregates or maybe the cement and sand. So this is now the dry quantity, you can say, if you multiply that with the same factor, okay, and divide it by 4, so we can have the quantity of cement, which should be 2.64 CFT, okay, 0.64 CFT cement. Now just divide this by 1.25, so we can have it in bags, okay, 1.25, and it should be 2.11 bags. Now, if you're working in MKS system, this thing can be different. The volume of cement bag can be different in MKS system, maybe in cubic meters, okay? It can be different. And sand should be actually the quantity of cement, which is 2.64 times the ratio of cement, which is 3. And this is 7.92 CFT. So I think it's enough for today. See you in the next video. And if there is any question you may ask.
Sir, please can slide send in group.
Send in group.
Yes, sir.
Okay, let me just save it so I can even send it. Okay. Is it QS class day 5? Is it day 5 or something else? Okay, I'm gonna convert this into PDF so you guys can read it even in your mobile phone.
Okay, sir. Thank you.
You guys may leave the class, okay?
Okay.
Okay, sir.
Allah Hafiz.
Thank you, sir. See you tomorrow, inshallah.
Inshallah.